Now dear student, we are going to discuss question number 4.2, and in this question we have to pick two scalar quantity out of some physical quantity that is provided here. Clear? So now let us try to understand each physical quantity one by one. Clear? So concentrate on a screen. Number one, if we talk about force, we can say force, it is represented by a vector like this, or we can write like this. If we have a constant mass, we can say F defined as mass multiply acceleration. Now we know acceleration is what? Vector quantity. So force is also vector quantity. But what is objective of this question is to choose two scalar quantities. Clear? So force is a vector quantity. Clear? Now if we talk about angular momentum, actually if you know formula of angular momentum, we can define this is angular momentum is defined as mass multiply, we can say V cross R, or we can say M R cross V. Clear? So now you can say here we have a cross product. Clear? R cross V. So we can say from the R cross V we are getting definitely here a vector quantities. Clear? Because this is a cross product and the output of a cross product is always a vector. Clear? So we can say this one is also a vector quantity. Fine. Now how can we define a work? So work is actually defined as a dot product of force and displacement. Clear? And always remember, my dear students, dot product always provides to you a scalar output. Clear? So we can say here work is a scalar quantity. So we can say here we are getting one answer, or one scalar quantity we have work. Clear to everyone? Now if we are talking about electric current, so now you can say, sir, if we define current, let's suppose I am writing here this is 2 ampere, and we are getting a complete information. Current is equal to 2 ampere. Let's suppose I am just taking an example. So current is defined as 2 ampere. And we are getting complete information. But you can say, sir, we know direction of an electric current is always from positive charge to negative charge. Yes or no? Direction of electric current is always from positive charge to negative charge. Clear? But my dear student, we can say electric current is having magnitude. Definitely it is having magnitude. It is also having unit. It is also having direction. But the most important part is here, electric current does not follow the law of parallelogram, or we can say law of vector addition. Clear? It does not follow law of vector addition. We can understand it like this. Let's suppose here we have 3 branches, or through which the current is going. Clear? Let's suppose I am saying here we have 3 ampere. We have here 4 ampere. So according to Kirchhoff's law, we can say the current that is going outside, it should be 7 ampere. Clear? But let's suppose if I am saying to you angle between 3 ampere and 4 ampere is 90 degree. Clear? If electric current is a vector quantity, the current that is going outside, it should be 5 ampere. Clear to you? But actually it happens that current always going, this is 7 ampere. Clear? It means we can say electric current is having a direction, but it does not follow law of vector addition. That's why we can put electric current in a scalar category. So from here we can say electric current is also a scalar quantity. Clear to everyone? Yes. Now if we talk about linear momentum. Clear? So linear momentum we can write like this. This is defined as mass in velocity. Mass is a scalar quantity and velocity is a vector quantity. So we can say linear momentum is also vector quantity. Clear to everyone? Now if we talk about electric field. Electric field is actually defined like this. This is force divided by charge. We know electric charge is a scalar and and force. If we talk about force is a vector quantity. So we can say electric field is also a vector quantity. Clear to everyone? Yes. Now if we talk about average velocity, so we can say average velocity, if we are talking about average velocity, is defined as total displacement upon total time. Clear? Now we know displacement is also a vector quantity, so this is also vector quantity. Fine. Magnetic moment. Magnetic moment, how can we define magnetic moment? It is actually defined, M vector, it is defined as IA. This is formula. Now we can say electric current is a scalar quantity, but area is a vector. Clear? Always remember, this is very, very important. Area is a vector quantity and the direction of area vector is always perpendicular to its surface. Clear? So we can say area vector, this one area is a vector, so we can say magnetic moment is also a vector quantity. Clear? Yes. Now if we talk about relative velocity. Now let's suppose if I say to you, we have a velocity a with respect to b. I am writing like this. Clear? So I can write like this, we can write it like this: velocity of a with respect to ground minus velocity of b with respect to ground. Clear to you? It means we can say here we have to take care magnitude as well as the direction. Clear? So relative velocity is always also a vector quantity. Clear? So what is our objective in this question? We have to choose here only two scalar quantity, but it is, I always advise to you, whenever you are solving such type of question, definitely you know the answer work and the electric current, but according to me you have to check each and every option so that you can also get some idea, okay, this quantity it can be a vector quantity. Clear to everyone? So this is all about this question.